Alright, so we have another Mathvisa video today. So our I can statement today is I can solve multi-step equations. So the first thing I want to do before diving directly into this equation that we have here is I would like to show you the steps in which we would take to solve a multi-step equation. So the steps to solve a multi-step equation are right here. Now, we actually talk about these steps as being new from when we solve two-step equations. So there's three different steps that you would have to add in order to solve a multi-step equation. Now, you just want to kind of go through a checklist in your head. Did you get rid of all the parentheses by distribution? Did you combine like terms then? Did you move the variables so there's variables only on one side of the equation? And then it's a two-step equation that you can solve. And then after that, the last step to check. So verbally or mentally in your head, you should go and say, did I check off all of these different steps? So with this one, draw our wall to make sure we're organized. With multi-step equations, this wall is more essential now than ever because there's going to be a lot going on with these equations that you need to organize yourself very well. So we're going to have to distribute first. So 4 times 5x is 20x. 4 times negative 3 is negative 12, so minus 12. On the right side, we get 7 times 2x, which is 14x, and then 7 times 3, which is 21. Now, based on these terms, I would say that it's smarter to move from the right to the left so that we keep positive coefficients in front of our variables. So, since there's an imaginary plus sign in front of that 14x, we are going to subtract 14x from both sides. So then, we get 6x minus 12 is equal to 21. Now what we're going to do is, again, this is now just down to the steps of solving a two-step equation. The nice thing here is that we didn't have to combine any like terms in this next step after distribution, so sometimes there will be some steps that you can skip because it's not necessary. So then we get 6x equals 33. Then we're going to divide both sides by 6, and we'll get x is equal to 5 and 1/2. Okay, and again, you could leave them as decimals or fractions. If you leave them as fractions, you want to make sure that you leave them fully reduced. At this point, you can go ahead and check your equation by substituting 5 1/2 in for both x's and make sure that it balances your equation. Okay, so let's go on to something a little bit more complicated. So, with this one, we really want to make sure the wall is drawn. So what we're going to do first is we're going to distribute this and get rid of all parentheses. So negative 5 plus 25x. The reasons why it's plus, negative times a negative becomes a positive. And then distribute this 5 to both terms in this set. So minus 40x minus 10 is equal to, nothing done over here because there's no distribution to be done yet. At this point, you're going to combine like terms. Now when I combine like terms, I usually suggest sometimes that if you're confused, you can just draw shapes around the like terms. So boxes around the constants and circles around the variable terms. And remember, you can only combine like terms on the same side of the wall. So when I combine like terms here, I'm going to get negative 15x minus 15 is equal to negative 12x. Now, which is the smartest way to move the variables this time? Well, I think that we should add this 15x because then I'm going to have x's on one side and then I only have one constant term on this left side. In addition, if I add 15x, I'm going to end up getting a positive over on the right side as a coefficient that's in front of x. So here I'm going to get negative 15 equals 3x. Divide both sides by 3. And I get x is equal to negative 5. So again, sometimes based on your strategy, you can create less work for yourself. And again, you would substitute back up in for all of the x's that occur. So there are 4 x's that occur to check to make sure that negative 5 is actually your solution. Okay, so today your bonus is right here. Enjoy.